Fiona. Now, Fiona is working on the three-joint robotic arm this summer, and she had a really interesting project where her robotic arm was actually phone controlled. So I think this project starts out pretty straightforward, but where students really get to shine is when they add modifications, and I think you'll see that throughout the projects. And I really love working with Fiona, especially with her modification. I think her modification took a lot of visualization and really advanced spatial thinking. So I really had so much fun working with her this summer. And yeah, I just really enjoyed getting to know her in a technical perspective, but also as a person. So yeah, excited for you guys to see her project. So here's Fiona.
Hi, my name is Fiona. I'm a rising junior at the Nightingale Bamford School, and my project is the 4-axis phone control robotic arm. The reason I chose this project is because I'm actually on the robotics team at my school. I do FTC, and some of you guys heard it. And this was really a way for me to get familiar with programming, since at my team I mostly do engineering, and I also wanted to get familiar with programming. So a quick overview of how the project works. There are 4 main components. One of them is the servos you see here. So these servos control the joints on my robotic arm. And there's also batteries, that's the power source, the HC05 Bluetooth module, which enables communication between my robotic arm and the phone. And finally, there's the Arduino Nano. The Arduino Nano acts like the brains of the operation, since everything ultimately connects back to it. So for my modification, I decided to add an extra joint. And as I mentioned before, these 2 devices communicate via Bluetooth, and so that's why I have a Bluetooth button on the right. So here's a quick demonstration. Arm up makes my arm go up. Arm down makes my arm go down. Servo 1 left makes my base servo turn left. Servo 1 right makes my base servo turn right. And claw open opens my claw. Okay, so it's not working, but it's okay because I do have a project demo. So I'll just skip to that part actually. So here you can see the claw opening and closing. And that was reset, which resets all my servos to 90 degrees. And here is a quick look at my block code. So one of the hardest things about my project was probably coding. I have little to no experience with coding, so it was extremely difficult for me to actually understand the code first. And in order to do that, I actually did a ton of research and basically commented on each separate line of my code, what purpose it served, and how it was implemented. And I can't emphasize enough on how much that helped me when I started writing my code for my favorite server. One of the things that I can take away from Bluestamp is definitely documentation. I don't like going in extreme depth on what I'm writing, and so going in detail made me realize there were so many concepts to my project that I didn't even understand. One of the concepts that I learned was PWMs, which stands for post-width modulation. And what PWMs do is they control the speed at which my servo goes at. In the future, I hope to take what I learned from Bluestamps and be able to contribute more to my robotics. Thank you so much. Any questions? Yeah.
How does your project connect to the app you've made?
Oh, okay. So, so there's a block that I use called send by number, and so that number will be sent to my Arduino, and in my Arduino, the specific action corresponding to that byte is set as a state. Okay. All right. Yeah.
When you you're doing the reset function, does it matter like the current position that the arm is in, or like what are you telling, like how does it know where it needs to go? It could be in any position.
Oh, okay. So my code actually constantly reads the position of the angle at which my servos are at. And basically, when I reset, all the servos will reset to 90 degrees. So it doesn't matter what position they're in.
So what was the 90-degree turns difficult or the civil motion? Okay. Which one? What was the 90-degree motion going up and down, the arm going up and down?
Oh,
the motion was difficult for you to attain, or the swivel motion and right?
I'm sorry, can you remind me?
Which one was most difficult for you to achieve in terms of the arm going up and down, or arm
Left to
rotating left to right?
I would say they were both equally difficult. I mean, I never had a lot of problems when I was coding that. So. Yeah.
Did you have any issues with powering your servos at all? Like, what do you think was like the most difficult problem within like powering and stuff, especially since like sometimes servos can be a little wacky with that?
Yeah. So I actually don't have any problems with power. My robotic arm uses 4.5 volts, but the reason it might be a bit wobbly is because of the center of gravitation. So the center of gravitation affects how stable my robotic arm is. So for example, it's ideal, a low center of gravitation is ideal for my robotic arm because that means my weight is close to my base. But once that weight shifts outside of my base of support, then my robotic arm will become unstable.